Hi, everyone joining. We're going to give it a minute or two here to let you all join. Hi, everyone joining. We're going to give it another minute or so to let some more people join. All right, we're probably going to get started. Go ahead and get started here. Hi, everybody. My name is Erica Diffenderfer, and I am one of the graduate advisors here in the Industrial Engineering and Operations Research Department at UC Berkeley. I want to go ahead and get started and introduce one of our professors and our head graduate advisor for the IEOR MS and PhD program, Ryder. So she's going to talk about herself briefly and then also introduce our other faculty who are here to talk about their research. So we're happy that you were able to join us. We do encourage you, if you have questions throughout the presentation, to use the Q&A box. And then also, we'll pause briefly after each of our faculty presentations if you have specific questions for that faculty member about their research. If you have general questions, though, we're going to have more of a Q&A session at the very end. So feel free to stay for that as well. So I'm going to go ahead and pass it over to Rhonda here.
Hi, thank you. Welcome. Yes. So I am the head graduate advisor, and I have to apologize in advance because we have a department seminar that I will be stepping out early for. And so please do ask any questions after I talk about my research. And I've lost track. Should I introduce folks before I talk about my research, or I'm not sure what I lost track of the order of the slides.
No problem. You can go ahead and introduce yourself, and I have the slide pulled up right now for you.
Okay. All right. Sounds good. Yes. So I am an alum at Berkeley, so I have an insider's view. It was a long time ago that I was a graduate student, but it's a great place to come for graduate studies. So so if you want to go to the research slide, then okay, I have to come back to that. So let me introduce the other folks. So go ahead and go to the next slide. Chian, so he's just started here at Berkeley, and we're thrilled to have him. And Ying is next, I guess. Ying. So she's just joined this year also. So 2 new faculty members this year, coming from the University of Minnesota. And then we have Zheyu Zhang, who's been here for a few years, a little more senior, and his area of simulation, and we're glad to have him here also. So just a couple of words about all the areas that we do research in at Berkeley. So optimization and algorithms, machine learning, data science, stochastic modeling and simulation, that's kind of where I fall, robotics and automation, supply chain, financial, energy, healthcare. And these are just some examples of things, and they're sort of cross-cutting. A lot of my research has to do with scheduling web server farms, and I guess we'll get to that next. So these are just some examples, but I work on generally large-scale service systems, like web server farms. And the first category here is things where there are compatibilities between different classes of things that need to get served or matched, and different classes of servers. And so an example is, at one point, I looked into the question of whether it would make sense at a call center to have, if you had press 1 for English and press 2 for Spanish, at least here in California, whether there should be maybe a press 0 button if you could speak both languages, you're bilingual. And so taking advantage of the flexibility in the server, and that's creating new compatibility links. And we showed that if you have things that are relatively balanced, that this is a case where it's a win-win, that the folks who are bilingual, by pressing that 0, they get faster service, obviously, but the system runs more efficiently, so everybody has better service. It's kind of a win-win situation, and you don't have to train the servers to handle questions in both languages, even if they happen to be bilingual. They don't do that. So it's taking advantage of flexibility that's already in the system. And then this dispatching in large computing systems. So how should you send work to a bunch of servers? And for servers that are sort of homogeneous, there's kind of classic results that if you know how much work each of them has, you send to the shortest work, or if you know how many jobs they have, you send to the shortest queue. But it turns out that if you actually know how long your job is, which you would sort of need to know how much work is at the different servers, it's actually a very difficult problem that you don't necessarily want to send a job to the shortest queue. And even if it's kind of a short job, you might not want to send it to the shortest queue. So there's a lot of interesting counterexamples, and I've been working on heuristics for trying to understand that. And also things where you take into account the usage of energy. And I think I will stop here and see if there's any questions about that, or about general program as in my role as head grad advisor.
Feel free to drop any questions you have for Professor Ryder in the Q&A, if there's any questions.
Okay, well, if you have any questions, going forward, just send me email, and I look forward to hearing from you. Thanks.
All right, if there's no questions, again, we plan to have a more general Q&A session at the end. We can go ahead and answer. We have one question in the chat here that I can go ahead and answer live. Applications are open for our IEOR MS and PhD programs for fall 2024 admissions. So yes, they have opened. So the application deadline is in December, and information about the application requirements, deadlines, all can be found on our website. All right, if we don't have any other questions specifically for Professor Ryder, we'll go ahead and move on. We'll hear now from Professor Yang. So I'll go ahead and pass it over to you.
Thank you, Erica. You can hear me? You can hear me, right? Yeah, okay. Yeah, so welcome. Thank you for joining the webinar. So my name is Chian. As Rhonda said, I just joined the department, and my specialty or focus is in transportation, supply chain, and logistics, and its interaction with marketplaces in particular. So I guess I can go to the next slide. So yeah, so I guess what is why I'm excited, or what is the interesting aspect of my research is, I think the most important part is I find exciting is it's at the intersection of academic development, but also there's a lot is about kind of industry application. So oftentimes kind of the type of approach I take is I look at a real problem, which is often generated from some companies and some organizations, and we try to abstract away some of the details that are not so relevant and trying to come up with some elegant academic solution that then we go back to kind of the real setting, trying to get our hands dirty to kind of implement this. So oftentimes kind of the ideal cycle of a research project I like is it has this kind of complete feedback loop. So this is something I found really interesting. And as a side note, right, so here I listed a lot of companies, like leading companies in this field, like supply chain, transportation, and platforms. And one of the benefits of considering Berkeley as a PhD program or master program is many of these like leading companies is actually located in the area. So you actually get firsthand access to these problems, which is a main benefit. So the next slide. Yeah, so as I said, so I think these problems are application driven, but also if you look at these type of problem, it also contributes to the fundamental knowledge of IEOR, right? So you must heard about inventory problem, network design problem, vehicle routing problems, queuing problems, Rhonda just said, right? So many of these problems actually you develop for that problem, but also it leads to kind of interesting methodology. So this is kind of another interesting aspect of it. So in particular, if you go to the next slide, what a majority of my work these days focus on kind of the interplay of these problems with platforms. And what's new or what's kind of interesting in this setting is that many of the participants on these platforms, including demand and supplies, they are actually all customers. So you're actually not able to dictate what they're able to do, right? You have to kind of properly incentivize them to achieve certain optimal outcomes. So if you go to the next slide, let me give you one concrete example. As what I said is, it's thinking about a simple problem of dispatching rides at an airport. I'm not sure how many of you are using these kind of ride-sharing services. So what happens is that drivers, they go to these airport, they have a designated queue, right? So the platform is going to give them a number based on kind of a FIFO, like who arrived the first, right? And then on the Ryder side, so here I'm showing you kind of a distribution of trips from Chicago O'Hare Airport, and you can see that there are rides that are kind of long, and then it's like cost like $50, and then there's also short rides which go to kind of nearby location that only cost like $10, right? So if you go to the next slide, what's interesting about this dispatching problem is if you think about kind of the natural way of running of dispatching these rides is go down the list like one by one in a FIFO manner, right? So the driver who wait the longest should have the highest priority. But because of this heterogeneity in terms of some trips are actually more expensive than the other, if you prioritize the first driver in the queue, it creates a bad incentive for this driver to cherry pick, because nowadays actually driver is able to see all the information of kind of where the rides go and then how much they can earn, right? So what they would do is they would solve some optimal stopping problem. They would keep rejecting the trips until kind of a high earning trip appears. So if you go to the next slide, so this will create a problem on the rider side, because if I am a rider that only want to go to a location that worth like $10, right? So if you go down the list one by one, many of the driver in the front of you is going to say no to me. So I'm going to wait a long time to get a match, right? So eventually, if you go to the next slide, what I would do is I keep waiting in this screen, and eventually I'm going to cancel the ride. So this is not good because we have enough drivers, but they're just like, they're badly incentivized. So we're not able to fulfill all the demand, right? So if you go to the next slide, and the slide after this is, so the solution we look at in a nutshell is injecting some kind of randomization in this process, right? So why when having some randomization helps, because if I say no to some request and the request is going to come to me in a randomized manner, so then that reduce my incentive to say no to low earning requests, right? So what the solution we propose is we divide the queue into several beans, and we are going to go down the list bean by bean, right? So we have a write request, we're going to send to the first bean in a randomized manner. And if someone says no in this bin, we send it to the second bin in a randomized manner until someone accepts it. So basically what happened is that this Ryder request is going to go down the queue much faster than before. So it does not get lost before kind of the patience of the Ryder explode. So we're able to show that this is able to recover some sort of optimal outcome compared to a mechanism which you're able to dictate what the driver is going to do. So if you go to the next slide, yeah, so this is kind of a nutshell of what the solution is, and if you're interested, you can look into this paper. But I hope I give you some flavor of what type of work I do, and this is a really exciting place to be. So I hope you will join us.
Okay, so if anyone has any questions for Professor Yan, feel free to drop those in the Q&A. Or any specific questions. And again, like I said, we'll have more general Q&A at the end here. Well, thank you for talking.
Yeah,
All right.
Feel free to send me email if there's any questions. Yeah.
Yes. All of our faculty's emails can be found on our website. Or if you reach out to our admissions email, we can also connect you with our faculty as well. All right, so we'll go ahead and move on. Professor Cui, I'll let you go ahead and get started.
Okay, so hey everybody. I am Ying, and as Rhonda said, I also just joined the department. So today I didn't prepare any specific research work from me, but I would rather give you a big picture about what I care about and what I have done in the past few years and plan to do in the next few years. So broadly speaking, my work is about optimization, and a little bit specific words it is about continuous optimization for the data science. And here, so continuous optimization means the decision variables in the problems I am focusing on doesn't have to be integers. So it can take arbitrary values in a certain interval. And before talking about all these keywords, let me first give an advertisement of my book. So if you want to know more about what I am doing, then here is on the right corner, there is a book that is recently published, written by me and my postdoc advisor, Ying Pan. So optimization has been studied for a very long time. And then people always ask me, why do we still need to study optimization nowadays? And my answer is usually because nowadays we are facing more and more complex data, and we need to use more and more complex models in order to extract useful information from all those data. And here there are some keywords about the data and the models that I care about. So for example, if we think about how to train a machine learning model to predict the medical treatment plan for a certain disease, for example, for a certain cancer, then what kind of issues are we facing about? So first of all, the data, they have very large scale and they are very unstructured. If you think about the clinical notes by the physicians, so they are very unstructured. They are not numerical values. And we need to understand those natural languages in order to get important information. And the medical data, they are also very incomplete in practice, and we have many missing data. The data can also have some errors. They can be very noisy, and they can be imbalanced. So imbalanced means, especially for the medical data, we may not have equally numbers of data for different age groups, different side effects because of different treatment plans, and also because of different the number of data different among different gender, different race. So all these kind of issues we are facing about. And given all these complicated things in the data, then in order to really get or train a good machine learning model to make a reliable prediction about different medical treatment, for example, the radiation therapy, or whether the patient needs some surgery or some chemotherapy. So how to predict the outcomes from different treatment plans, especially if we want to take the personal or the individual information into this model, then we need to have complex models. So by complex models, it can be like a very non-convex model, means the model, the objective function or the constraints in the model, they can have multiple peaks and multiple values. They can be non-differentiable, means there can be some sharp corners in this problem in the feasible region. And because of the nature of all these kind of machine learning models, and because we want to predict what will happen in the future for the future patients, then there are some non-deterministic issues in this model, because we cannot see for sure, like for each medical plan, what will happen after we deploy those kind of plans. And we want to be risk aware. And for any applications, for the safety critical applications, not only in the medical or healthcare domain, but also like for the self-driving cars, we also want to be risk aware. We want to be risk averse in a way that we want to prevent the worst case, some worst case behavior of the models. And we want the model to be robust over the adversarial attacks and over some rare events. And sometimes a model can have multiple agents participating in the whole system, like the government and the individuals. If, for example, if we want to consider what is the best allocation plan for the vaccine during the pandemic, now we also want to take into consideration the individual behavior or reaction given different policies made by the government. So it can have multiple, the model can have multiple agents, and it can have some very complicated structure like the hierarchical structures. So some of the participants, they can be leaders, they have to be the followers. And so which means actually this is not a single agent optimization model, but this is rather a game. And there are also some practical considerations. For example, well, especially we want to make a medical plan or we want to predict the outcomes of the medical plan, now we want to consider the fairness issues among different age groups, among different gender, or among different race. And the medical data, there are always some privacy issues. The hospitals may not be allowed to share all the important information for the patients. So we need to consider all these kind of issues in order to really train a good model. So can we go to the next slide? Okay, so given all these kind of like issues or difficulties, then what I am trying to do is to design a reliable, scalable, efficient, robust computational solver for different kind of models arising from different kind of applications. And usually how to design this kind of solvers is we need to look at the particular structure of different models. So they are now the generic optimization problems, like to minimize FX, which you have no information. But whenever you are facing a real application, then we will have a particular structure of that model. And the question is, what is that structure? Sometimes there are some explicit structures, like the sparsity of the data or the sparsity of the solution or the low rankness, but sometimes we only have very implicit structure. And we need to use mathematical tools to detect those implicit structures in order to design the most efficient computational solvers. Can we move to the next slide? Okay, so I think about my research into 4 aspects. So usually we begin with some variational theory. Variational theory means we want to characterize for example, the global optimal solution or the local optimal solutions using different, using variational theories. And we also want to understand whether the model itself is sensitive or robust to the data perturbations. And another thing is from the variational series, we want to consider or we want to understand whether what is the implicit structure hidden in this model, so that when we move to the next phase, the algorithm design, we can fully take advantage of all those structures. But algorithmic design is the core part of my research. Is how to, so whether we want to use some first order method or second order method or zeroth order method or doing some randomization of algorithms so that it can effectively solve the models. And we also want to understand like whether we can guarantee the algorithm converge or not, or what is the complexity of the algorithm to show like theoretically whether the algorithm is efficient or not. And after theoretically understand the algorithm, we need to implement the algorithms as a numerical solvers, and then finally deploy it into the applications. And sometimes we may realize that, okay, after we try those solvers into the real applications, then it may not work very well. Then we need to go back maybe to the very beginning to further examine the model and see what is the bottleneck and then whether we can improve our algorithms. Can we go to the next slide so that I can give you 2 sample applications that I am currently working on. So the first application is from the healthcare, which is actually currently supported by the National Institute of Health. So we consider the breast cancer, a particular disease. And so for this breast cancer, there are so all those data, they are highly imbalanced. And this data, we work together with the medical school at the University of Minnesota. So these are real data. And when we first look at those data, we realized the highly imbalanced issue in this data. And this imbalance is in terms of many dimensions. It is in terms of the age groups. And it also in terms of the different side effects for different treatment plans. So you can imagine maybe some kind of side effects, they are not commonly seen by your medical treatments. So we only collect very limited data for certain side effects. And then how to leverage this data so that we can train the model to prevent this kind of things happen. And okay, so the goal for this kind of project is we want to train a neural network model that can effectively predict the outcomes for different treatment plans. And another application I'm interested in is for the design of the reliable energy systems. And especially because nowadays we want to integrate the renewable energies into the whole system, like the wind power, other green energies. And with this kind of new renewable energy, then there brings a lot of uncertain issues because the production from all this kind of renewable energy, we cannot see for sure what will happen. So because they depend on different weather conditions. And then the question is, if we integrate all this kind of green energy into the power system, then how to design the allocation plan or even the production plan so that we can still meet the demand for the residents and also for the production of different factories. So this is a kind of stochastic programming models, and we consider a multi-stage stochastic programming model to capture the information from the whole system. And the question is then how to design a reliable and also very efficient numerical solvers to solve these problems, especially given the large scale of the data for these kind of applications. So I also care about the applications from other domains, but here I just want to give you a kind of flavor of what I am trying to do. Okay, so that's about my research.
All right, thank you. If anyone has any specific questions, feel free to drop those in the Q&A. I do see one more general question in the Q&A right now about the class size of the MS program and acceptance rate information. We do plan to post student profile information on our website, so stay tuned for that.
I just want to say goodbye. I'm off to the seminar, but if anyone wants to email me questions, so bye-bye.
Thank you, Rhonda, or thank you. Like I said earlier, in case you missed it, on our website, we do have our faculty listed and they have their contact information. So if you would like to contact any of our faculty members, please see our website for that information. All right. Let me go ahead and move on to our last talk for today. So I'll go ahead and let you take over here, Professor Zhang.
Sure. Can we move to the next slide? So this, I'd like to use this opportunity to briefly share this research project where it's a joint work with my PhD student here at IEOR and a bunch of collaborators at Amazon. And this is a research project that integrates some knowledge from stochastic processes, simulation, statistical inference, and machine learning. And this, just like the three professors shared, as you can see that at IEOR, our research very commonly needs to and enjoys the pleasure of integrating knowledge and toolbox from different fields and areas, and they are all together used to try to provide better understanding or solve an optimization problem of the system. Maybe next slide, Erica. So in terms of A/B tests, I like to use this one slide to just briefly share with the audience here, particularly for those who are less familiar with A/B test, where when we talk about A/B test, it's an abstracted terminology where the idea is to test when we have two designs or two algorithms in the system, and one is called treatment, the other is called control. We like to understand whether treatment is better than control. If you think about what we are actively using on our mobile phone every day, you know, the different apps that we use for communications, for shopping, for other different purposes, there are always constant updates on these softwares, these apps. Maybe, for example, the user interface, the platform wants to change that, or maybe that the platform likes to use a new algorithm for recommending different contents. And the idea is that whenever there is an innovative idea developed on a platform, they like to use A/B test so that they can scientifically know whether the new design is better than the old design. Okay? So if we think about the scale of A/B tests, there are kind of millions of A/B tests that are run on different platforms every year. So that's a very large number. And the underlying mechanism is very simple, that it's a very simple statistical tests that we give some samples to the treatment, some samples to the control, and then we try to answer the question listed on this page. Okay. And what's special about this project is that classical A/B test assumes stationarity, meaning that it's a commonly made assumption that's also referred to independent and identically distributed. There are a lot of data-driven methods, and particularly about A/B tests, that assumes the data we observe are stationary, in the sense that they have the same distribution, the outcomes of the same distribution. And however, in a lot of business environments, such assumption is violated. So if we still stick to the standard methods that assume stationarity, it may cause issues. Erica, maybe next page. Erica, yeah, thanks. So this is a plot that illustrates what we mean by non-stationarity. And in particular, this plot, the C here represent control, T represent treatment. And these are two metrics for data privacy reasons and masking what they exactly the magnitude. But we see here, these are metrics that related to sales, revenue, customer experiences. And we see that on the axis, they're different day of week, and also within the day, they're different time of day. We see that there are significant differences across the time of day and day of week, meaning that when the customer arrives on the platform at different time of the day of the week, they may have different experiences overall. And this is what's so-called non-stationarity. Next slide. And this is another illustration that shows sometimes this, by the way, this is a plot of another A/B test across 2 weeks of horizon. And we see that they're not only non-stationarity within each day, within each week, but from 1 week to the next week, we see a lot of differences. So these non-stationarities overall, they just arise commonly in the platforms, and ignoring them will cause issues to the A/B tests in terms of having some negative effects on the accuracy and efficiency of A/B tests. Erica, next slide. Okay, so, and this is my last slide that kind of gives a short summary of what we do in this research project, where we provide an analytical framework to analyze and understand the impact of non-stationarity in A/B tests. And in this part, we use the knowledge of statistics, stochastic processes, and we develop new estimators, and these estimators use knowledge in statistical inference, machine learning, and also stochastic processes. And the goal is to better understand what is the issue caused by non-stationarities, and we are developing new tools to solve those issues. And third item is also a lot of IEOR related research cares about that. We want something that's simple, that can work, can solve hard problems, but at the same time, we like to provide some theoretical guarantees so that we can understand under what circumstances our methods can be fully trusted. Okay? And fourth, this in collaboration with our collaborators at Amazon, we implement the proposed estimators, and which can help the A/B tests better solve and handle the non-stationarity phenomenon. Okay? So this is my last slide, Erica.
Thank you. Thank you to all of our faculty for presenting. We do plan to have a little time here for any questions that you might have for our faculty. But before we do that, I just wanted to share some ways to get connected with our department. So some social media, as well as our admissions email address down at the bottom. So if you have any questions specifically about your application or about the program you'd like to know more, and you don't get an answer during the session, feel free to send us an email and we can help you out that way. I do see we have one, let's see, a question in the Q&A. So please use the Q&A feature if you have any questions, and we'll work down those as we get those. The first one is, are recent IEOR theses available to view? The UC Berkeley does have the theses dissertations available online via our UC library. If you'd like to get like a more direct link to that, feel free to send us an email, the admissions email, and we can provide that for you. On our website, on the IEOR website, we do have more on our research page, it's more faculty research, but feel free to check that out. You can see what faculty are involved in different types of IEOR research, different areas, as well as like publications and things that our faculty are working on currently. So we encourage you to check that out. Any other questions for our faculty here? All right, so our next question says how to apply for teaching assistantships. I'm a Fulbright grantee looking for an MS in industrial engineering. So PhD and MS is a little different, or each of those are a little different in our department. Currently, the PhD students have or do teaching assistantships years 2 through 5, but the MS students are not guaranteed a teaching assistantship, but they can feel free to apply to that. We do send the students information, or students who are admitted, we send them information about teaching assistantships. So that is an option, but it's just not a guarantee because the PhD students are prioritized for the teaching assistantships in IEOR. There are assistantships available in other departments, and students can feel free to seek those out. All right, and then another question, and feel free to ask questions about research as well for our faculty members, but we can answer questions about more general questions about our program as well. Is the master's program a bridge program to the PhD? So the master's program is considered a terminal degree program, and students who are interested in the PhD would need to apply for the PhD program. And if a student who is an MS student in our program wants to complete the PhD, they would need to apply with the rest of other students or other applicants applying for the PhD program during the regular admission cycle. All right, can we have the presentation? We will be posting this presentation afterwards, so feel free to check our website. We will be working on posting our presentation that we did last week, which was more of a general information session about the IEOR MS and PhD programs. So feel free to check that out once we have that on our website as well. All right, maybe one of our faculty members can help with this question. Will MS students be able to participate in research? How common is it to see master's students doing research in IEOR?
Maybe Ying, I can try to answer this question. MS students in that program, I think there's Erica just mentioned that there's a curriculum for courses and other activities, and based upon those, if there are additional time and energy that the MS student have, they definitely welcome to reach out to faculty to talk about research, and in particular, an MS student, I think, is by default will have a faculty advisor so that they can complete an MS project. And then how common is to see a master student doing IEOR research? So that's, I think, partly what I said was, MS student will have a faculty advisor to get a year-long project, and they're going to do a final presentation or write a master's kind of project thesis about that. And Erica, there's another question. Would you like to answer that, or I can?
Yes, let me see. So, and I do want to just add on one quick thing with the last question is our master's students, there's 2 different plan types, but one of the plan types is the project or comprehensive exam. So a lot of our students do end up choosing the comprehensive exam path. So I just wanted to add that. Let's see. So all of the research presented is very interesting. When joining the PhD program, how can we get involved in projects like these? So I know Professor Zhang just briefly mentioned, reaching out to professors to, talk to them about their research and, figuring out who you have like common interests with. That's one thing that we encourage students to do, especially PhD students in their first year. I don't know if y'all have anything you'd like to add to this answer here. But yeah, so we definitely encourage our first year students to get to know our faculty, get to know what our faculty are researching, and to learn more so they can choose who they'd like to work with for their dissertation. All right, another question says, are admitted PhD students assigned to a specific faculty advisor in their first year, or can it be determined later? So like I kind of hinted at in the last question, they're not first year students are not assigned a specific faculty member. Students use that first year to talk with the faculty and figure out what, where they want to focus and who they want to work with. So that's typically determined towards the end of the first year. So yes, there's some time there during the first year to decide. Either of y'all would like to add anything?
I guess sometimes the faculty members may also offer some courses related to their research, and that's a good opportunity to to know more about the faculty's research interests.
Yeah, I agree with Professor Ying that it's a good opportunity to take the graduate courses, and you will, and to talk to the faculty in those courses. That's offers a natural opportunity to interact and to learn more about the fundamental knowledge in the related research.
Thank you. All right, so we have some more questions here. How often does a master's program student graduate with a business arising from their graduate work? I'm not sure. Maybe one of you can help with this question. I'm not sure if I understand the question exactly. Maybe if you could clarify the person who submitted.
Or yeah, is it a startup or what's the meaning of a business?
Yes, maybe if you could clarify the person who submitted, that would be helpful. Let's see. Another person had said that they are interested in applying for the PhD, and they see that one of the areas listed is machine learning and data science. And they want to know how in depth how in depth are the classes taught, and how closely do you work with the CS students and professors? So, do either of y'all have anything to add to this question?
I think first there is, in terms of how closely do you work, I think to clarify if it's referring to the faculty, I think that's of course the faculty's own choices to choose how close they themselves engage with other departments. And if the U refers to PhD students, I think it's also a free choice here. Berkeley is a very open kind of cultural that there's like not like a hard boundary that you in IEOR department, so you work on research only in A, B, and C. It's very encouraged that they're into interdisciplinary research collaborations going on. So that's my answer to that question. Erica?
All right. Another question we have is, what is the career outcome of IUR master students from past years? We do have a page on our website. It says, or it's called "Where Our Alumni Work." So that provides some information about where alumni go after they graduate at UC Berkeley. We do plan to add more specific information to our master's page, so stay tuned, like I said earlier, for that information. All right. Okay, so we got clarification about that first question. How often does a master's program student complete it, or like, let's see, have a startup after their graduate work? I'm not sure if we have that information. Do either of you know more about how many students typically have startups after they graduate from the master's program specifically?
I myself, I think I know students who graduate from our master's program first, right after their graduation, go to work for a company, and then after a few years start their own business. But to my knowledge, because I'm only here for 5 years, and also interact with not all master students, so I don't have complete knowledge to this question. Whether whether they directly get into a startup, or after a few years at a bigger enterprise.
Thank you. All right, so we have a question for Professor Ying, and let's see, I am familiar with your recent monograph on non-convex, non-smooth problems from your experience in research projects that have a potential application in industry. Where does non-convexity arise the most?
Yeah, this is a very good question. So I take a very positive view of this non-convexity or non-smoothness. So if you think about it, it is usually by design. We want some non-convex model or non-smooth model in order to extract more useful or important information from the data. So if we are talking about non-convexity, then I'm not sure whether you're familiar with deep neural networks. So that is nowadays is a very typical example of non-convex models. So because we have the multiple layers of the deep neural networks, and because of those activation functions, so the model is the overall model in order to train the neural networks parameters in the model is a non-convex problem. So that's a simple example. And another related problem is there are also some non-smoothness arise in the practical models. And we design those non-smoothness in order to get some structure of, for example, this solution. And if you have heard about Lasso models, so which is used for the variable selections, and why we have a non-smoothness, the L1 knob in that model is because we want the solution to be sparse. So we manually add all those kind of features in order to more faithfully deal with the practical situations. And there are a lot of more applications in practice.
Thank you. All right, so another question we have is, let's see. Oh, I think it's about transfer credit. I would suggest if you have specific questions about transferring or things like that, I would suggest emailing us using our grad admissions email and provide more information about your specific situation. That would probably be a little bit more helpful for this question. If you have questions about your specific situation regarding like your application or the program, and it's like highly specific, I would definitely suggest, sending us an email so we can talk about your situation. And you can also set up a Zoom meeting to talk with an admissions advisor as well to get more information about your specific situation. Any other questions? All right, another question we have. There are so many interesting courses in the IEOR department. Is it possible to participate in multiple research areas within IEOR? Maybe I'll let one of our faculty members answer that.
Professor Ying, would you like to answer the question?
I guess it's common to have the co-advisors for students so that maybe you can, yeah, try different research areas. That's my understanding. Is it?
Yeah, I think it's of course possible, and it depends on the interest, the time management, right? And also, I think if you're like super interested and dedicated to devote time to multiple projects, I think that I have seen those situations before, so that's certainly possible.
Thank you. Any other questions? We have a couple minutes here. All right, if we don't have any other questions, that's totally all right. We can go ahead and end our info session, but we do encourage you to check out our faculty members on our website. You can click on each faculty member and see a little bit more about what they're researching, their bio, and their contact information. You can also check out our website to see the research. Like I mentioned earlier, you can see which faculty members are working in each research area, as well as see publications from our faculty members. And then as we mentioned earlier too, you can check out let me see, our application information, yes, on our website, and future information sessions and future or information about the application and the deadlines specifically for the MS and PhD program as well. So we encourage you to visit our website. I see a question quickly about application fee waivers. We do have information posted on our website. If you have specific questions about your situation or about the application fee waiver information on our website, we encourage you to reach out to us through email, and we can help with your question. All right, so we're going to go ahead and close out our info session. Feel free to email us with any other questions that you have, but we're so glad that you were able to attend and to listen to our faculty. We appreciate you coming and hope you have a great rest of your day.
Thank you for participation. Thank you, Erica. Yeah.
Thank you. Thank you all.
Bye.
All right, bye-bye.